So the plan was to have roughly 20 minutes of the presentation, and then the rest of the time is discussion and questions and like that, right?
Yeah, we will start with introduction to Yantra, and then
Yes.
you will have your presentation, and then we will go to question answer, and then we will have a vote of thanks.
Okay, good. Sounds good.
Good evening, everyone, and a very warm welcome to our respected guest speaker, distinguished guests, participants, students, professionals, and robotics enthusiasts joining us today. So, I am Safula Bhattrai from Robotic Association of Nepal, and it is my pleasure to be your host for the Yantra Global Webinar Series, a knowledge sharing initiative under Yantra X organized by the Robotic Association of Nepal. So, in today's webinar, it is about the robotics and intelligence autonomous system under the broader theme Society 5.0 and Intelligence System. And we are truly honored to have Professor Ricky Latokatano, Chairman of the Robotics Society in Finland and Vice Chair of the International Alliance of Robotics Association, as our keynote speaker. So, today's program will also include an interactive Q&A sessions at the end. So now to begin with, I would like to invite ER Bikas Kurung, President of the Robotics Association of Nepal, to deliver the welcome address.
Thank you, Safola, for wonderfully starting this program. Thank you, Professor Ricky, for accepting our invitation to be part of this Yantra X global webinar series. Robotics Association of Nepal has been organizing a lot of events, and being Robotics Association of Nepal, we have this responsibility of making sure that our robotics community, our Nepal has knowledge of different technology that are being grown all over the world, and having the experts from all around the world in our connection, we need to leverage that. And we thought, okay, we should start this global webinar series so that we can transfer the knowledge from the global experts, also create a networking platform so that our students, our engineers, our entrepreneurs, they can have access to the global experts, and then they can learn from them, they can be guided from them, and they can be mentored from them. So this Yantra X global webinar series is a kick start of that attempt from our side. Definitely, Robotics Association of Nepal has always focused ourselves in terms of capacity building through different initiative. Definitely, Yantra is one of these. We have another initiative called Mesh Tech, where we involve all our women, girls who wants to be part of robotics. And then we have an initiative called Ujjwal Education. We directly partner with the schools, engineering colleges under these Ujjwal Education programs, and then deliver different robotics and AI related content to the schools. And we are working with a lot of organizations within the country, such as Save the Children. We have this project in Madhes, Bara right at the moment. We are working with the European Union as well. We are working in Madhes and Gandaki province. We have our programs already running with Ministry of Education, Science and Technology in early warning system. We are working with more tech ventures to work on humanoid and quadrupole robots, soon bringing it to IT colleges and engineering colleges. We are focused on policy level advocacy. That's where we are promoting different robotics and AI access centers, different learning programs to the schools, to the engineering colleges as part of the government initiative. We are definitely working with the global organizations. I'm glad to have Ricky on the Professor Ricky with us, because he is also the vice chair of International Alliance of Robotics Associations. I'm secretary of the alliance itself as well. We are a part of also global robotics clusters, World Robot Cooperation Organization. So making sure that our talents from Nepal, they also, when they think of going global, they have all the platforms ready through Robotics Association of Nepal. So definitely, as I said, this whole Yantra X global webinar series is to transfer the knowledge. It's also give access to our robotics community with the global experts, and then make sure that our robotics activities are vibrant, and we make sure that our robotics community learns from the learns at the right time in the real time. So that's where our focus is. That's what I would like to say, and request Safala to take forward the program.
Shripika sir, for your kind words and warm welcome. So now, to begin further, I would like to invite Mr. Rishabh Raz, Manager of Robotic Association of Nepal, and our former coordinator for Yantra X, to give a short introduction about Yantra X, its vision, and its work in robotics and innovation in Nepal.
Okay, thank you, Sapola ma'am. Looking forward, it was a great pleasure to present my previous experience at Yantra. Thank you, Professor Ricky, for joining us, and thank you, Team RAN and Team Yantra, for providing me the platform for this. Yantra X is an intelligence and entrepreneurship festival with the theme of Society 5.0 and Intelligent Systems. This is a festival, so the timeline of this festival is started from May and it will be concluded in the December 2026. And the locations are multiple, so the final event will be, or the IRC International Robotics Competition will be organized at the Tasutrangasala, Kathmandu. Yantra was launched in 2011 by Robotics Association of Nepal. Over 12 years, it was grown into Nepal's largest and most celebrated tech festival, bringing together robotics, AI, entrepreneurship, and innovation under one roof. The festival brings creative professional technologists, fostering co-creation that combine art, technology, and service and science. Not only this event has produced a lot of talent and lot of global entrepreneurs for this from Nepal. The main mission of this event is to create intelligence robotics industry in Nepal by 2045, which is set by Robotics Association of Nepal. The major programs in Yantra X will be under the International Robotics competition. There will be Yantra Wars, that is basically a robotics fight. And followed by Yantra Soccer, that is a robot football, Nirian, that is a underwater robotics competition, Micro Mouse, that is a mouse size or mid-size robots will be competing in the event. And then after we have a Sumo or autonomous Akhada, that will be the combination of the Swarm robotics that will be competing in this during that event, Yantra Autonomous Akhada. Then we have Yantra Learning event where a lot of workshops and events will be organized. That is the 3D printing, AI, ML, Arduino, drone, computer vision, and different AI algorithms as well. Then we have Yantra President Cup, that is for Yantra Kids, where we organize this specific event for under 18 years group, or we can say under the school students. The participants will be from the students under class 10. Then after we have Yantra Business Cup, that includes Yantra Expo and the Soft Bot Robotics Hackathon. The winner will be incubated for 6 months, where they are growing from the seed to the one of the implementing company of this ecosystem of Nepal Digital or robotics ecosystem of Nepal. And we have also a robotics and AI conference in that, where there will be a keynote presentations, paper presentation, panel discussion over the work and the policies what will be implemented or will be more important for the Nepal. Then we not only organize the national level event, we organize provincial level event, that is a regional event. Nepal has come up with 7 provinces, so we have now organized four provinces and followed by concluding in the capital city of Nepal, Kathmandu. So we are organizing in provincial Yantra, Sudur Pasim Yantra, Gandaki Yantra, Mandesh Yantra, Kosi Yantra. Now we have a lot of events as well. So I'm looking forward for the participation from the various streams and academies, institutions, and even there are few events which is open for everyone to participate. So I welcome everyone to come on board and participate in this one of the renowned and one of the best and one of the important and one of the biggest event of the South Asia. Thank you, everyone. Thank you, Ms. Safola. Over to you. Thank you, everyone. Have a good time.
Sir, for sharing the vision and the journey of Yantrax. So now we are moving towards the main part of today's program, the keynote session. So it It is my great pleasure to introduce our keynote speaker, Professor Ricky Latocatano, Chairman of the Robotics Society in Finland and Vice Chair of the International Alliance of Robotic Associations. So he also has more than 25 years of experience in robotic automation, robot safety, and human-robot collaborations, and he has contributed a lot of both research and industry. So we are truly honored to have him with us today. So let's warmly welcome Professor Ricky Latocatano.
Thank you very much. Let me just share my screen. Hopefully you can now see the starting slide. Can you please confirm you see the slide? So I suppose it's visible. Good. So thank you very much for the introduction and invitations. Happy to be here and give you a short overview of the robotics, partly looking from the direction of Finland and partly in general. Small confession I need to make. Officially, I don't have a professorship at our university. I'm working in a similar role, but not a full professor. But nevertheless, that everything else is correct. So I have about 30 years of history in industrial robotics. And what I wanted to present you today, I collected from partly from the viewpoint of Finland. We have a lot of space, we have a lot of forest, we have a lot of water, but we are also quite engineering-oriented country. For example, Nokia, which you may know from mobile phones, actually did manufacture also industrial robots in the 80s. It was actually the first PC-controlled robot in the world at the time, but they don't exist anymore. One of the new interesting startups is, for example, this Kellu that makes airships. So it's a blimp drone that can be used in many applications. But let's get to the point. So I divided my presentation into 4 parts, a little bit about robots in a daily life and what's there, how those are affecting, what might be the new directions, a little about industry, which is my home domain, manufacturing and industrial robotics, what are the recent developments there. Then, of course, a little bit about humanoid robots. They are the hot topic in robotics at the moment. And then some predictions, what could be the future of robotics. So let's get started with the topic itself. So robots have been in our daily lives for quite some time already. If we take, for example, the vacuum cleaning robots, they fulfill the definition of robot. They can work somewhat autonomously. And they have developed a lot in the past 10-15 years. Now the programming doesn't take ages, but still there are some things to develop. For example, what I experience from my home, that it takes quite a lot of time to clean up first the house so that the robot can start vacuuming. And there is one recent solution for this, the newest model, which has a small arm, so it can pick up the socks and things that don't belong on the floor. Also, these can now define where you have carpets, where you have hard floors, and they can clean it. They can also mop it and wash it and so on. So there's a clearly development. And what I can tell from my own experience, that they actually do better cleaning job than my teenagers did some years back, but still development to be done. Even there, although the technology is quite mature. Then also, I think getting more common nowadays, at least in Finland, we have these delivery robots, which you can order groceries from the shop. And these are my videos, the ones on the left-hand side. It works perfectly on the summertime, but in the middle here, you can see a video from the same route in winter. And actually, even if Finland is the only place in the world where these Starship robots have a separate winter tires, they still don't manage, because their navigation algorithms and the intelligence doesn't know that the other side of the street would be clear from snow and this side of the street is not. So then it's stuck there and This is one video I took on my way to work. So I was trying to help the robot, but I think it never got where it was going. Also, as I mentioned, Finland has a lot of water, and here are some examples of floods. The robot thinks there is a road, but now actually there is a lake on the lower right-hand corner, and then it floats there with the ducks. And the other one is we have lifting bridges that open up so that the sailboats can go underneath the bridge. And for some reason, this poor little robot didn't notice that the bridge was open and it went into the lake. But it floated, so it's a good thing. Maybe if you find some kind of a propulsion system for these robots, then it can deliver groceries also to the ships. But what is good thing about these sort of flaws in technology, that they make these systems human. And then when people are scared of robots taking over the world, I think these are not the robots that will take over the world. So they kind of like also make it more humane, and then it's easier for people to accept the new robots, because sometimes people are scared of new technologies. Then if we think about autonomous driving and we go from these small delivery robots to autonomous systems that actually transport people, things get again a bit more complicated. I don't remember how many of these I have tested or sit in there. These first videos are from 10 years back, and during that time, during the fall, when the leaves were falling from the trees, the laser scanners could see the leaves, and they thought there's a collision possibility, and that the vehicle didn't move at all. But since then, the navigation algorithms, all the sensors have developed a lot, but still you don't see so many of these autonomous machines on the streets. So there's still a lot of development to be done to make them more effective, more safe, and more flexible. And that is actually something that there's quite a lot of work done in Finland. How do you manage when you have unstructured environment and harsh conditions like the snow and hails and such, what we have in Finland? This is also from very close where I live. There has been some tests with these systems, and the challenge there, for example, is that when you have a pile of snow on the road, the car doesn't know, is that a fallen down person or is it a snow pile, and that affects a lot the navigation algorithms, so that tends to be quite bumpy rides. Also on the lower right hand corner there you can see actually my house in the background, but not my car. As you can tell, the intelligence of the robot or the AI couldn't necessarily tell that actually that's a parked car under a pile of snow. So how do you then navigate and so on? So what I'm trying to tell or say here is that when we go from a structured environment to unstructured and same changing environment like our world usually is, it becomes quite a bit more complicated, and hence we need to still develop the intelligence and the detection and the perception capabilities of these robots. So still a lot of work to be done there. And that's also one of the areas what we research at Tampere University where I work, and we do collaboration with Sandviks, a Finnish company that has been building autonomous mining machinery already for 25-30 years. And they can work above ground and underground, and they can work autonomously. And what's the great benefit here brought by the technology is that now the working of a mining machinery operator is an office job. He doesn't need to go into the noisy, dusty environment outside. He can sit in the office, and the machine does all the boring, difficult, repetitive tasks, and the human only is involved when decision making is needed. So here is one good example how technology can change our working life also quite a lot. Of course, requires a lot of expertise and development to build machines like that. And about this development and AI tools we have experience from our university. Here you have one example about physical AI and when we are applying it to the real world. And you can see here a wheel loader that has been trained by a human by recording human operation. And although this kind of filling the bucket with the gravel seems like quite a simple task, it can be very difficult for the AI and machine to master because it involves driving back and forward, detecting what is the friction, how is your wheels turning or are they slipping. You need to control the boom, you need to control the bucket. And when the AI model doesn't have the context of this kind of a work, it can do quite stupid things as you can see here. But this video is from 5-6 years back, so since then things have evolved a lot, but it gives a good example how these physical AI things, they are quite difficult when we are working in a physical world, not only bytes and digital zeros and ones. And still, a lot of things needs to be developed when we go to really unstructured environment like forest. Ponsse is a Finnish company doing forestry machinery, and they have investigated, could you make an autonomous harvester that could go into the forest and cut the trees needed. And currently it's still impossible because there's so much sensory data, GPS data, things needed that the current computing power is just not enough. It's too complex. But it doesn't mean that these kind of harvesters didn't have any AI or robot features. They actually do quite many. So the operator only does certain selections and then the harvester can, for example, fall down the tree, cut it, everything happens autonomously. So you can make the cognitive load of the harvester operator smaller because basically it's been investigated that driving this kind of a machine in the forest, actually you need to make more decisions than a pilot operating a jet plane, a commercial plane. So there's more things to be decided. So it is quite stressful handling everything that you need to know to run these machines. So a lot of things have been done, a lot of robots, AI tools, machines are being operated in our daily lives and outdoors. And also, of course, in industry, where industrial robots have been used already for over 65 years by now. And there you can quite easily manage car manufacturing and electronic manufacturing when you have big series and you have a lot of products to manufacture. But the trend nowadays is that people want more individual products and they want more customized products. So it means that the manufacturing industry needs to be more flexible. And this is something one of my colleagues is working in the at the university. I don't know if you hear the sound from the video, but you can see the subtitles. So basically what we are investigating here is if you need to do real collaboration with the robot, you don't have your hands that you can press buttons or use user interfaces. Or what we are investigating, how you can use voice control and gesture control to communicate with the robot so that the robot has some cognitive skills and understanding that you don't need to program it, but you rather tell the robot what to do. And this we do by utilizing visual language action models and different large language models and other AI tools to kind of generate commands or instructions for the robot. And here is some examples from this EU-funded Jarvis project where human and robot collaborate in applying these carbon fiber plies, and the robot is controlled by voice. So this is a very common development in industrial robotics, is trying to make the robots easier to use, and rather than programming the robots, you could actually just tell them what to do. And there are not really any commercial applications yet, but a lot of research is done all over the world on this topic. But if you look from the manufacturing industry where the robots are actually used, the trend seems to be that simple robots are more and more popular. This is not a simple robot. This is a big welding station by Pemamek, a Finnish company. I think here it's welding for railroad cars. And these are very big, very expensive, and very complicated. But instead, the trend when you do simple things, if you don't manufacture railroad cars, but something simple still, you probably want to take this kind of a simple, easy to use collaborative robot where you don't need a robot expert to do the welding, but instead you need the welding expert, and he can learn or she can learn to use the robot by just pressing a couple of buttons and actually showing the robot manually what to do. So simple robots, simple tasks, easy to use, that's clearly a trend in manufacturing industry, and that's also a good entry to the world of industrial robotics because they are usually quite not so expensive, easy to use, so the ramp up time and getting payback from these robots is much easier than investing in these huge systems. But then a lot of challenges still to be made in manufacturing in our daily lives. Would this be something to be solved? They clearly think so, that this is something that the robot looking like a human would do all the work for the human and solve all the problems. But I have a little bit my doubts there. Don't get me wrong, I think these are great machines. They are mechanically very good at the moment. These are some videos I took from IROS last autumn in Hangzhou. There were numerous different companies developing humanoid robots, mostly Chinese. And one Professor Songsun Su gave a good talk, and he mentioned some of the robots that he likes the honesty of the humanoid robot industry because the head of the robot is hollow, meaning that they don't really have that good brains yet. And these are great for dancing, these are great for kung fu, they are great for backflips, but no one does that for a living. So basically, when you go into a dexterous things that need good fingers and touch, then these robots don't excel that well anymore. And that's one of the biggest kind of like development challenges at the moment is how do you train these robots? Because if programming an industrial robot with 6 degrees of freedom is already quite challenging, these may have 46 degrees of freedom. So you cannot use traditional rule-based programming anymore. Instead, you need to use training and AI tools, machine learning, and so on. So then you either record how humans are doing it, or you teleoperate these robots and then get material for training the neural networks so that the robots could behave autonomously. And there's still a huge amount of work to be done because very big part of human dexterity and manipulating things is that we have very good touch of sense and very good vision system, our eyes also. And that's something that these robots don't quite yet have. And when you train these using the visual language action models, very seldom those include the haptics, meaning the sense of touch. So that's why a lot of development is still needed, that how do we train these robots to be intelligent enough so that they can manage autonomously. Also, what it requires is more computing power, which again needs more batteries and so on. And the truth is that quite a few of these robots are actually strong enough that they could carry strong enough brain with them. So you need to connect them to a bigger computer to be able to calculate all the needed things. So humanoid robots in industry, I don't quite see it yet for some years, but I must admit that the development in past 2-3 years has been so fast that you never know. These are certainly developing well, but still a lot of work to do. Then, well, a lot of work to do. What will be the future of robotics and intelligent autonomous systems? Well, we have a lot of technologies related to robotics. Here are some presented by the EU robotics in a bit older roadmap already. It takes a whole village to build a robot for sure. We need experts in various different areas, and then we can develop a technically very good robot. But also what we need to do is listen to the customers, because no one, well, except a robot nerd engineer like me, wants to buy a robot just to buy a robot. They want to do something easier. They want to make their life easier, more pleasurable, or so on. Same applies for the companies. They want something done. So we need a holistic approach. We need various different expertise to kind of like fulfill all these areas, and they need to be able to communicate, because not a single person can handle all of this. And it's very important to keep the needs of the users there. So what I see as the future of robotics is here. The coming generations that will take what we have now and develop it further. So who knows how it's going to be, because the younger generation, they have grown up with the smartphones and the technology. So hopefully they also have the approach and needs for developing everything. So what I think is that the future of robotics is people. We still need them, because the robots will not develop the robots. And one good example of this is the city of Riihimäki in Finland. They have robotics program for every single student in their city, starting from the preschool. And they include robotics in everything, not to study robotics, but sort of like how to think about the modern technology as part of your life. And I think they have a very good, realistic and healthy approach towards technology. Our society's small contribution to this is the industrial robot book, which we wrote for users of industrial robots, so that they could learn how to use the robot as a tool, not as some special machine that you don't know how to use. So we'll see. Hopefully that helps if you work in industry. But I think all in all, to conclude, I think we need to start building robots for humans too, not only for engineers. There's a small joke in there. I'm a hardcore engineer. I like robots. I'm married to a human, my wife. She hates robots, but she tolerates our vacuum cleaning robots because it can make her life a little bit easier. So I don't need to vacuum, or she don't need to vacuum, except downstairs where the robot can't go because we have stairs. But I think we need to start thinking that what we need the robots for, not only to develop robots for the sake of robots. So that's my short overview. Take this as a impression or the ideas of a cranky, cynical, middle-aged engineer who has worked with robots quite a long time and hopefully works for a bit of a more time too. Thank you so much.
Sir, for your insightful and inspiring presentation. So we will also now move into the Q&A session. Participants are kindly requested to post their questions in the chat box or use the raise hand features. If you like to speak directly, we will take the questions in order. And before we proceed into that process, I would like to inform all the participants that a digital certificate of participation will be provided to attendees of the webinar. A certificate registration form will be shared in the chat section shortly, and we kindly request all the participants to fill out the form carefully, as the information provided will be used to generate your certificates. And also please make sure that to submit the form to receive your digital certificate. Thank you. We can move forward for the Q&A session.
I would like to ask the question from this side, or engineer Sankar sir, you want to ask? Okay.
Well, not really. I just wanted to, just thank you for this session, and was sending an emoji clapping actually.
Okay, thanks so much.
Okay. Because sir, over to you. I really don't have much question, but if I have to ask anyway, in the end I'll see. Yeah, over to you. Thank you.
Okay, please raise your hands. Although I will start the question from my side, Professor Dr. Ricky. This is overwhelming for the audience where we have right at the moment, because Nepal it's really in a nascent stage. But what would you suggest for all the engineers over here, or aspirants over here? How do they can start their if they want to work on robotics arm, for industrial robotics arm? It should be, it's more in terms of the technical knowledge they want to gain, the step by step. You mentioned about vision language models, right? So these technicalities they should learn, so that they can understand about the industrial robotics arms that you have already.
Well, I think kind of like I see the industrial robots as a fairly simple tool to get something done in the industry. So it's kind of like it's a product that you buy from the shop and then you start using it, and it's more, I think, on the industrial robotics, the more it's about mechanical design and what kind of actuators, what kind of tools, what kind of accessories you need for the robot so that it can do some industrial manufacturing task. But I think if you want to kind of like use robotics in different areas and where I see the more potential, then I think nowadays you can get started with quite cheap products that you can order from eBay or Alibaba. And I think if you build yourself a robot that has some sensors for sensing the environment, some control to navigate and move around, and somehow kind of react to what the sensors see and then behave differently and do all the programming and stuff for that, you can actually, or you need the same skills and you can learn the same skills with the hardware costing $10 or $20. And then the same principles apply when you work with the very expensive new big robots. So it's kind of like to train the basic needs or the robotic skills, you don't need expensive equipment. And I think I would think the biggest potential technically is in the other robots than industrial robots, and they are kind of like, they are more like ready-made tools that you can do a limited amount of things, but then if you build the robot yourself you can do whatever. So I think it's if you understand what's going on, what affects what and so on, you learn very important skills that then you can apply to real robots, if you like. But then I think if I continue for the industrial robots nowadays, you have a lot of free simulation tools that you can program industrial robots in simulated environments, and you can learn easily how to use them. I think Fanuc, ABB, Universal Robots, they all have free training material and free online environments when you can train with just a computer. So you can also learn how to use an industrial robot without actually ever seeing a physical industrial robots. Of course, then you need to also the physical world at some point, because you cannot simulate everything, but at least sort of like the simple preparations, what buttons to press, what commands to use, those you can learn also just by using online simulation tools. That was a long answer to a simple question, but
Thank you, Dr.
How important is ROS2? I say that if you need to learn ROS, then learn ROS2, not the ROS1. I think for manufacturing industry, ROS still is not that big part, because they tend to use the proprietary softwares and stuff. But I think for the research community and also for all the kind of like service robotics and those, they are using ROS more and more to be able to communicate with other devices and stuff. So I think learning ROS 2 is definitely an important skill if you want to move into robotics. Yes. Well, now I saw this chat window. Okay, yeah, there's a lot of good questions. Will robots industry cause problems related to employment? I guess it depends on a lot what kind of industry we are talking about and what kind of requirements do you have for an industrial worker. I think if it is very simple, let's say that if it's something that you don't need training for and you can easily learn, and it's something kind of like dumb that if the human works like a machine without thinking too much, without problems to solve, I think then she or he can lose her job because of the robots. But then if it is something that you need to know how to weld, or you need to know how the materials behave or something like that, then it's less prone that your job will be affected by the robotics. But well, the main goal of automation is to reduce human work. So in that sense, it's kind of like built in that the robots will take over the works, or not the work of the humans, but I would say the tasks that are too dangerous or dumb or boring for the humans. So I think then robots enable us to use the skills of the humans to something more profitable, more meaningful. So I think they kind of like replace some of the jobs. But this is the discussion that has been going on since, I don't know, 1700, the Lud is the first sewing machines and so on. So it's there. Okay, what skills? I a little bit answered that. I think ROS and, well, physics, math, control theory, programming, definitely. That's something that even if AI can do a lot of programming, I think you need to understand the basics still. What tasks that humans do today will completely take over within 20 years. I think at least somewhat that if your working involves a lot of walking around, like in a factory, transporting stuff, that's probably something that it's better to do with robots. I think someone has a hand up. So. I don't know what to do with that.
I think he left, you know.
Yeah, I don't know, can the participants just, if they have, can they open their mics, they could ask the questions, so.
Yeah, they can, Safala, can you moderate?
So I was about to ask, is STM32 level of programming enough for the robotic industry?
Sorry, could you repeat what level?
The STM32 level of embedded programming, is it enough for the robotic industry?
I don't actually know that what level would be enough. I think it depends a lot on what kind of tasks you are working with and what kind of robots. I think in a sense the programming of the robots is not hugely different from programming or doing computer programs. So I think if you kind of like have the basic knowledge of programming and structures and everything, I think you can learn what is needed for the robotics. Of course, then if you are programming some very low-level motion controller of the robot, might need different skills, but it's I don't know, is there clearly any kind of like a level that you need to have? The better programming skills you have, probably the easier it's also to work with the robots. Okay, then there's a question, I think, in the chat about the flexibility of robots, and I think this refers that they are not flexible enough. I think mostly the flexibility goes or is a challenge for the computers and the brains of the robots, that we kind of like probably need more sensors to detect the environment and see what's going on than the perception. But I think mostly the biggest challenge is that we don't have the training data yet to train the robots. So we can use AI tools for detecting emotions from the pictures, and we can detect persons and humans and cats and dogs and whatever, because you have an internet full of training data. But then if you need to do dishes and how to wash a cup or a glass or a plate, we don't have the training data for that. So I think the data sets for training the AI models for the robots to be more autonomous, I think that's the biggest challenge, is that we need more good quality training data. Okay, Nepal spends significant resources building roads in difficult terrain. Can AI-assisted construction equipment reduce cost and improve safety? Well, I suppose at least improve safety for sure, that you could send the equipment where the humans can go, but I don't know, can it reduce cost at the moment? I suppose it depends on the availability of construction workers and what are their salaries and so on. But I think at the moment, I would wait for the construction machinery to be able to work on the flat ground before implementing them in Nepal, because you have quite a different terrain. So I would say that yes, maybe in a future, but probably not currently. Biggest technical differences between industrial robots and military robots. I think the industrial robots are, in that sense, simple and easy robots, because they are mounted usually on the floor. They don't move anywhere. They just work on where they are. Military robots, they need to move in a terrain. They need to be more situation aware. They need to detect the environment and stuff. So I think industrial robots work in very structured environment, which is known. And for the military robots, you don't have any idea of the environment where they work. So I think there's a huge difference there. I think it's sort of like they require much more situation awareness and that stuff.
Can I read a question for you?
Yes.
So this is from Mr. Susan. He has said that I am in the very early phase of building an autonomous delivery drone. My main technical objective is to achieve reliable state estimation and tracking without GPS for GPS denied environments. Right now, I am learning the fundamentals of ROS2 and its implementation. So touching physical hardware, my plan is to train and validate the drone virtually within the NVIDIA AI simulation environment or any similar tool. I currently lack resources. Want your suggestions?
Okay. Well, I don't know how to help with the resources, but I would probably try to check what's been done on this topic, if you go to GitHub or elsewhere, are there any kind of like free resources that can be used, and maybe some of the universities or research centers that might be working on this. So I don't know, would they have somehow resources available that could help you with that? So and then I know that this is something that some universities in Europe are working on. So maybe if you like, you can drop me an email and I can forward you if I have any resources that I would know. But honestly speaking, all these drones and outdoor robotics is a bit outside my own expertise. So in that sense, can't help you unfortunately with that. But I can see if there is any kind of like resources I could link you to progress with your work.
There are a few questions at the top as well. Safala, can you read that out?
Current research gap in robotics and intelligent autonomous systems that undergraduate students can realistically explore. I think it's probably I would point out to the kind of like different AI models and then training data and stuff. And what I have understood from some of our students who work that you can get quite good models that can run already on your own computer, even if slower. So I think kind of like getting training data and kind of like annotating that and sort of having, I think, data for household use and other things. I think that probably could be something that could be investigated. So I think that's the biggest gap at the moment. And I think also the one thing is that kind of like multimodality, that when you need to try to understand and perceive the environment, can you use vision and other sensors and combining that sensor data into something meaningful to kind of like understand the environment better? I think those kind of topics probably are.
At the top, like it's from Mr. Chandis. So he has asked, do you think robotics in industry will cause problem related to employment, loss of employment opportunities? And if so, will this hinder the development of such robotics technology?
Let's see, I think I might have answered that partially already, that question, if I got wrong. Don't remember wrong. Let me see. At least there's one about agricultural potential, labor shortages, climate challenges. I have seen several kind of like developments on the agriculture robots, and the simplest one are being kind of like wheelbarrows, that if you need to transport something on your farm, if that can happen automatically. And I think also kind of like drones have been used for spraying pesticides or spreading the nutrients or those kind of things. So I think it's also it's possible, but of course it's always that even the simple robots, they do cost money, and I think quite often it comes to the economies of scale, that if the farming is small scale, it's very difficult to get effective and cheap enough robot that it pays off. But I guess it also depends a lot on the farming, so maybe it's worth kind of investigating that, what can be done with the robots currently and what's not. So I don't see it as impossible, but challenging, probably, for sure.
Mr. Dahal, if you were a student starting over today, how would you prepare for a career in robotics and what would be your path for learning?
Well, career for robotics, it's I think it's kind of like you need to have some sort of a holistic view, that you need to know a little bit about programming, you need to know a little bit about mechanics, you need to know a little bit about sensor technologies and combining those and stuff. And then I think no one can master all of these. So then I think it's to kind of like understand the big picture and then focus on some area of the robotics. I think that's probably the best. But what to learn, what would you need to know to be a roboticist? A little bit of everything, but then maybe focusing on something. So I don't know, does that answer the question, but
Vani, what tasks that humans do today do you think robots will completely take over within the next 20 years?
yeah, I think that's also something I tried to answer already, but it's a difficult one. I don't know really, but I think something that, for example, I think transporting material in industry, so taking things from warehouse to the manufacturing place and then back to the warehouse. I think the mobile robots, that will be something that they take over. But about the humanoid robots, autonomous vehicles, those robot cars, I don't know. I think it's probably gonna take a little bit longer than that. But I wouldn't mind taking a robot that would do all the cleaning in my house. First taking everything in the right place and putting everything in order, and then vacuuming and then mopping the floor and then wiping the dust from the tables. And I would be happy to find a robot for that, but I don't know if one will be ready on my living time. Okay, there's a new question. Interested in building physical? Oh, okay, that's a good question by Initial. Building physical robots, how can we balance mechanical design, electronics, control systems, and programming without becoming too shallow in all areas? Well, that's a very good question. I think it kind of like becomes most common the mistake students make. I think they are very good in innovating things and building stuff and making new ideas. Usually, I think something that if you need to do something by a deadline, like exercises I'm running here, the biggest challenge is that students never have a plan B. They go with the plan A and they think that that will work, and then when it doesn't, then they are surprised that, hey, what happened? Or then when we have some assignment and they saw that, yeah, it works fine yesterday evening, but it doesn't do the mail. So it kind of like you need to explore more of the options. And also seems to be that when people don't do that much things with their hands anymore, they don't understand the mechanics too well about what kind of structure does it require so that it's rigid enough and it doesn't break and it's strong enough. So I think it's at least the people, students in Finland, if they are from the computer side, they don't know the mechanics, and maybe vice versa. But I don't know how to find the balance. Maybe I would say that the same thing again, that find a group where you have a mechanical expert and programming expert and so on, and then try to make them work together so that they all know a little bit, but then they master in some area. What kind of microcontrollers devices programming algorithms is sufficient to build a robot that can learn from the pattern mistakes and provide data? Ooh, very good question. I cannot answer that. I'm a mechanical engineer. I work with robots that you can buy ready-made. I cannot make a robot from scratch myself, but I think with all the kind of like Arduinos and Raspberry Pis and those kind of things, you can already make a functionable robot. But then, of course, depending on how difficult things it need to solve and what kind of like how much intelligence you need to have, I think the computing power is probably then the limiting factor.
For this wonderful Q&A session. Now, to formally conclude today's session, I would like to call Mr. Omkar Jaiswal, General Secretary of Robotic Association of Nepal, to deliver the vote of thanks.
Thank you, Ms. Satwala. Namaste and good evening, everyone. As we have reached to the conclusion of this session of Yantra X, Society 5.0 and Intelligent System, it's really honored to deliver a vote of thanks on behalf of Robotics Association of Nepal and Yantra. Today we have witnessed much more than a webinar. We have witnessed powerful ideas, experience, and vision of the future of robotics and the intelligent autonomous system. First and foremost, I would like to express my deepest gratitude to Dr. Ricky, President of Robotics Association of Finland and Vice Chair of International Alliance of Robotics Association. Thanks for sharing your invaluable knowledge, global perspective, and practical insights. Your presentation has helped the participant and to the audience who are present here and watching us from the different social medias under how the robotics, intelligent autonomous systems are shaping the future of industries, societies, and humanity itself. We are equally grateful to our President, Secretary, Executive members for their continuous support and leadership and the commitment to the advancing robotics innovation and the technology developed in Nepal. My sincerely appreciation also goes to the team of Yantra X, our organizing committee, technical member, volunteers, and all the individuals who work behind the scene to make this webinar possible, and obviously upcoming event also. Most importantly, I would like to thank to each and every participant joining us in this webinar and joining us from the different social media. We are delighted to see more than 100 of participants representing schools, colleges, universities, different companies, industry, professional societies also, Navin sir and engineer Shankar sir is also here with us, researchers, enthusiasts, students, and innovators from the different background. Your participants sends a really powerful message that the future is of technology and not just building the machines. It is building technology is not only just building by the machines alone. It is built by the peoples who are willing to learn, collaborate, innovate, researching the new things, learning. Whether we are like a student dreaming of our first robotics project, or an educator inspiring future engineers, or an industry professional seeking for the innovation solutions, you are like important contributor to this technology development to our society. As all of us we know, Nepal continues its journey towards the digital transformation and the innovation. Collaboration will be our greatest strength. No single institute, organization, company, or country can save the future alone. Together happens when knowledge is shared, partnership are formed, and talented people work together as we work in our association. Therefore, I encourage all the participants, robotics and tech community to stay connected, continue learning, building meaningful collaborations, and transfer today's idea into tomorrow's solution. So let's create technology that are not only intelligent but also responsible and beneficial to our society. I still remember few years back we like work with the ADB for sanitation worker, how they can like really get the dignified life in our society. So uh, this webinar is not just to be ended of a conversation, but the beginning of a new collaboration, innovation, and the new opportunities to build the future together. So thank you everyone for your participation and support. Hope to see you in upcoming events, webinar, and Yantra. Get ready for the Yantra. Thank you.
So much, Mr. Omkar sir, for your kind vote of thanks. Now, I would like to request every participants to turn on the video so that we can take the group photo. So everyone, could you please turn on the video? All participants, please, I request you to turn on the video. Also, on the behalf of Robotics Association of Nepal and the Yantra Global Webinar Series team, I would like to thank Professor Vicky Latokatano, ER Bikas Guru, Mr. Rishabh Raj, and Mr. Omkar Jaiswal, and all the participants for joining and making this event successful. We hope that today's session gave you useful insights into robotics and intelligent autonomous systems. So, thank you all for joining us. We look forward to seeing you in future Yantra X event, webinars, competitions, and the other following programs. Have a great evening, everyone. Thank you.
Thank you very much.
Bye.
Everyone.
Bye,
Thank you,
everybody.
Professor
Bye-bye.
Ricky. Bye. Have a great day. Good dinner, everyone.
Thanks. Bye-bye.
Bye-bye, Professor Ricky. Bye, Safala. Bye, Omkar.
Until next time.
Dr.
Yeah.
Yeah.
See you soon next time.
Next time, we would love to see you in Nepal, Professor Dr. Ricky. अलि ढिला भएछ इन्भाइट गर्नलाई ल अब यसलाई ल अब यहाँ कोही कोही मेम्बरहरू हुनुहुन्न भने ऱ्यान्डको मेम्बरसिपहरू भर्नु होला हामी तपाईहरुलाई यस्तो प्रोग्राम गर्दै जान्छौं Rishabh, Amrita, let's end this. Bye Vidur, bye Suraj, bye Saroj, bye Anushka, bye Sujan, bye Pooja, bye Milan, bye Anuj, bye Sam Krishna. The end government. Mohin, bye bye.
ला हो थाहै दिएर आउनु